this number, we have our Cn, which is the total capacitance in series, is equals to 3.3 times 10 raised to the power of minus 8 farad. Now we are to solve question A. A, they said the potential difference, let's keep it here. The potential difference between the end plates, between the end plates, in bracket V total, then this is the total. So at this point here now, our V total, our potential, the total potential difference, the total will therefore equals to our total charge, because the charge, that is the charge that flow all through, divided by the combination of the three capacitor. So divided by our C, we now have that our total charge is equals to 5.0 times 10 raised to the power of minus 5 coulomb over 3.3 times 10 raised to the power of minus 8 farad. So therefore, when we divide this, when we complete this, it will be same as 5.0 divided by 3.3, we're going to get 1.515 times 10 raised to the power of this 10 raised to the power of, we have minus 5 here. Then this particular division here also brought minus. Then we now have on our denominator we have minus 8. So put this into bracket. So therefore, our answer is now got 1.515 times 10 raised to the power of minus 5 plus 8. So we have 1.515 times 10 raised to the power of plus 3, because minus 5 plus 3 we have minus 5 plus 8 we have 3. So this is our total volt, the total voltage for all the three circuits. But it was only 500 volts that got into the first. Maybe they pick our data here. We have our V total is equals to 1.515 times 10 raised to the power of 3 volts. Question number 2, the B part. Question number the B part. They say determine the charge on each capacitor. So therefore, the charge on each capacitor, your answer can be written this way, that when connected in series, what is connected in series? The capacitor. When the capacitor is connected in series, the capacitors have the same charge. The capacitor have the same charges. So therefore, the charge on each capacitor is equal to 5.0 times 10 raised to minus 5 coulomb. So this is just the quick answer to the B part. Now I'll take away this. Then we go to the third question. They say the third question here says that determine the energy stored in the system. Determine, question C, determine the energy stored in the energy stored in the system E. Now, for me to calculate the energy stored in the system E, we have two formulas for that. Either we take energy is equals to the integration of V dq, or we take the integration of V dq, which is same as VQ, which is same as VQ. So we can take this, but remember that for the energy stored in the system, it started from somewhere. It's just like your phone. Your phone, you want to calculate the energy stored in your phone. It means it actually started, your phone battery might start from 0 to 100%. So it started from one point to another. The energy that's stored here, it started from one point to another. So this will be divided by 2. So at this very point here, we actually know that our Q, we note that our Q is equal to CV. Our Q is equal to CV. So let's substitute CV into Q. So we can now have it as our energy is equal to V multiplied by, wherever we say our Q, we substitute it as CV. So we have VV here. So energy can also be 1 over 2 CV squared. 1 over 2. So this is the formula we're going to use to find our energy stored in the system. Why these two? It's because we are taking the average. We're taking the average from the initial to the final. So now therefore, let's take this. So therefore, our energy E is equals to 1 over 2 multiplied by our C. So our C, which is the total in the system, because they say in the system, not in the first capacitor, but in the system. Then we're using the total capacitors, which is 3.3 times 10 raised to the power of minus 8. So therefore, multiply by V. Our V, what is our V? We got our V to be 1.5, 1.515, right? Multiply by 10 raised to the power of 3. And here they said all square. So therefore, our E is equals to 1 over 2 times 3.3 times 10 raised to the power of minus 8 times. So what we do here is that we can you square your 1.5, you square your 1.55 and also multiply this. So when you square this, you take 1.515 times 1.515 times 10 raised to the power of 6 times 10 raised to the power of 6. So when you multiply this and this, then you have times 10 raised to the power of 6. So therefore, we are going to arrive at an answer. When you multiply all of these, we're going to multiply arrive at an answer to be 7.6 times 10 raised to the power of minus 2 over 2. So our E total, the energy stored, is therefore final answer 3.8 times 10 raised to the power of minus 2 joule. So this is our final answer. Yes. So please, you support the channel by liking and also share it with other departments. I think we have 3 departments that are also offering the same course. Please share it with other departments. Thank you.